Welcome. I am Brandon Fulk, your instructor for today's lecture, in which we will explore fundamentals of control theory with an emphasis on sensors and actuators. This lecture is complemented by the reading The Fundamentals of Control Theory, Chapter 1, Big Picture. Our agenda for this lecture will require you to contemplate an open-ended question, provide the basics to the fundamental of control theory to achieve our learning objectives, and ask that you reflect on the question at large. Before we get started today, I want to share with you the learning objective for our lecture on fundamentals of control theory. By the end of this unit, including our lecture series and our upcoming active learning session, you should be able to reflect on the role of sensors and actuators in feedback control systems, applying theoretical concepts to real-world scenarios. So we've defined our lecture structure and learning objective. So how do we get there? I want you to consider a process that we will refer to several times during our instructional module. The process that I want you to consider is, what process did you grow up with that has grown in complexity and ability to react to feedback in real time in recent years? The process is simple in nature. It's really open-ended. But in recent years, it's transformed how we do things, moving from an open to a closed system. So before we get started on the fundamentals, I want to share with you a little bit of my frustration as I've worked through the module in preparation for the lecture today. It's imperative that we learn the basics relative to the language when it comes to fundamentals of control theory. But as you learn that, the frustration sinks in is that we take for granted some of the verbiage and or processes that are in place in our day-to-day lives, but it is imperative that we do establish the basic language so that we can connect the disciplines and the functions that are within that. And so today we want to kick off with discussing the control system. The control system is a mechanism that alters the behavior or the future state of a system to a desired state. And I show here in this diagram that it starts from left to right. You have the basic parts, you have the components, the subsystem, and then the overall system. It's really a collection of interconnected parts that require specialists like sensor experts, actuator experts, digital signal processing experts, and other team members to bring the whole system together. It is important to understand the simplest format of a system so that you can tackle the whole. Hence, we introduce the block diagram to illustrate. The box is a system. It's the center of everything that we do. Input drives the system, and then the output is what the system generates. Block diagram provides you with a schematic, but we must dive deeper into the development of the system. Therefore, we continue to build on our foundation by the introduction of the open loop. The open loop is a well-defined input and output. It's a simple process. The key components are the controller. It's designed specifically to convert a command into an appropriate actuating signal. The actuator manipulates variables. It's a device or motor that is responsible for controlling the system. And the process, it's the behavior or the outcome that we are looking for. Examples in my childhood would include a washing machine or a dryer in which we just input our clothes, we turned a knob, set a time, and we walked away. Can you think of others? We all know life is far more complicated, So we must capture the complexity by means of the closed loop, which is a dynamic system with variables, errors, and adjustments. Key components remain the same as the open loop, but we must insert the sensor. The sensor measures the controlled variables and passes it along to our controller. Now we can compare the sense variable with the command variables and generate an error term in which the system adjusts and minimizes the error, bringing it closer to our desired outcome. Now that you have a better understanding of dynamics systems and how actuators, controllers, and sensors are related in the simplest form, what open loop to closed loop improved system have you witnessed in your lifetime?